كازيانتاج. You hear me well? Can I start?
You can start. Can you share your screen?
I will share my screen. Can you see my screen?
Yeah, no problem.
My work is design and simulation of PID neural network controller for BMDC motor speed and position control. The contents of our work, we will speak about introduction, BMDC motor modeling, design of PID controller, design and structure of ANN PID controller, results, finally, conclusion. Let's start with introduction. These drives have been historically the backbone of applications that demand precise speed and position control, including robot manipulators and home appliances, because of their low complexity, excellent reliability, adaptability, and attractive cost. The motor should be accurately controlled to provide the desired result. Thus, the speed controller must carry out a variety of functions under a wide range of load conditions. Control's main goal is to improve the model's performance and enable reliable operation. Conventional control algorithms like PID have some drawbacks. A major problem in applying PID to speed controllers is the nonlinearity effects of the DC motor. DC motor nonlinear properties such as friction, saturation, design constraints, and mechanical variations caused by the operation conditions can affect the conventional controller performance. So we need an intelligent controller, which is a type of control system that employs different computing techniques with artificial intelligence, such as artificial neural network. There is currently a strong interest in control science and practice for integrating between classical automated control methods with artificial intelligence methods. We can control complex and weakly formalized objects and process, such as artificial neural network with a conventional method that are capable of eliminating system nonlinearities. The distributed and inherent parallel design of ANN can be effectively exploited in order to control the electric motors. So I'm in this study to design an artificial neural network-based PID controller to control the speed of a permanent magnet DC motor in two methods. A detailed analysis is performed based on the simulation results of both methods. The proposed controllers are numerically simulated for various test conditions, including set point changes, step changes in the load torque, and parameter variations. The suggested techniques were compared in a comparative study with a traditional PID controller based on the transient response specifications. Let's speak about the BMDC motor modeling. The DC motor used for this study is BMDC, which controls the speed by armature voltage control method. To model this system, we use the system's mechanical and electrical dynamics. These two equations show us the mechanical and electrical dynamics of the system. The parameters of the BMDC motor are shown in the following table here. The assumption that the nonlinear effects of the system are negligible may result in poor control performance. So we designed the control system by taking into considerations all the nonlinearities as backlash, load zone, and friction. The simulation model of the system with nonlinearities in the following figure, presented in the following figure. Here, this figure represents the response of the system in open loop. We notice here there is a big overshot in the curve that's undesirable. So it's crucial to design a speed controller of the DC motor at different desired speeds. Now let's speak about design of PIG controller. Proportional integral derivative control is one of the earliest control strategies used in all fields. These occasions describes the action of the PIG. The weighted sum of all the gains is used to change the process via controlling. We can tune the three constants of the PIG controller algorithm to meet our specific operational needs. By tuning the PIG controller by Ziegler-Nichols method, and after some other tuning, we will fix the values of PIG parameters as follows. KB is 35, KI is 260, KD is 0.05. We will use this value to initially train the network. Now let's speak about design and structure of ANN PIG controller. The study of the neural networks in control systems to enhance the degree of automated processes and economics effectiveness of industry is of a great importance. The error between the system output and predicted values can be minimized by using a neural network PIG controllers in place of conventional PIG controllers. We have designed the controller in two different ways depending on the inputs, outputs, and the structure of the neural network. Here the first controller tested in this study is made up of a classical PIG controller plus a neural controller, which we denote as ANN PIG1. In short, it incorporates the advantages of neural and PIG controllers. Traditional PIG directly regulates the controlled object using a closed loop, while a neural network adjusts their control gains, KB, KI, and KD, based on the system operational condition to achieve a performance optimization. The model of ANN PIG1 controller with BMDC motor is shown in this figure. The inputs of the controller are the reference speed, the error signal, and the output signal, where the outputs of the controller are derivative gain KD and integral gain KI and proportional gain KB. The function fitting is performed using a feed-forward neural network with two layers, whereas the transfer function that we used are a linear transfer function and a tan-Sigmund transfer function for the output layer. The structure of this network is 10-3. The data are gathered from the traditional PIG controller's closed loop response and were used to constitute a database to train the network. We use a repeating sequence signal as a reference signal. Here the second controller, it mimics a PIG controller. It's designed to generate a control signal that allows it to control the velocity of the BMDC motor. 3 inputs are fed into the controller to generate a single output. The structure of the ANN PIGT is depicted in this figure. The input of this, the controller are the error signal between the reference speed and the actual value, the integration of the error signal, and the derivative of the error signal, where the controller outputs is the control signal of the BMDC. The structure of this network is 15-1. The data are gathered from the traditional PIG controller closed loop response and were used to constitute a database to train the network. Let's now speak about the results. The performance of the BMDC motor with different control strategies, 2 artificial neural networks and conventional PID is evaluated on the basis of rise time, settling time, and maximum overshot. 3 testing scenarios are carried out, which are set point changes, disturbance rejection, and uncertainty rejection. 3 different objective functions, which are the integral square error, integral obsolete error, and integral of time-weighted obsolete error. Indices are calculated for each case in order to analyze the performance of each controller. Here, we test the robustance properties of the BID and ANN controllers. To set point variations, we use a random reference signal, the output reference response of PID, ANN PID1, ANN PID2, with random reference is shown in this figure. The transient response specifications and performance indices of random reference are represented in this table. Here we can show that the smallest values of all the performance indices for ANN-BID2, while ANN-BID1 comes after it, BID controller had the worst values for the performance indices. In order to test the robustance of the designed controller to the disturbance inputs, a random load torque signal is used with a 270 reference speed. The output response of all the controllers are shown in this figure. The proposed controllers and the response specifications and performance indices are shown in these tables. We also see that the proposed ANN-BID2 has the smallest values of all performance indices, where the ANN-BID1 has the smallest values of the rise time and overshot. Last, we test the performance of the percentage controller against the uncertainty rejection. We have changed the value of P from 0.002 to 1.5, and also we changed the value of G. The output responses of the 3 controllers are shown in this figure. Also, the transient response specifications and performance indices see in these tables. The 2 proposed controller, ANN-BID1 and ANN-BID2, show improved performance for disturbance rejection than the BID controller. Last, the conclusion. The works investigates the effectiveness of enhancing a controller designed for BMDC motor. The speed of the permanent magnet DC motor is controlled using the proposed ANN best PID controller in 2 methods. The simulation model of the control system has been established based on the analysis of the mathematical model for the BMDC motor based on the electrical and mechanical occasions of the BMDC. First, a BID controller is designed, and then the BID parameters are tuned using the Ziegler-Nichols method. Next, an ANN-based PID speed controller is designed. The performance of the proposed controller is validated by subjecting the BMDC motor system to angular velocity tracking, set points, load torque changes, and parameter variation tests. The results show that the speed control of the DC motor by an NN-based PID has better performance, high resilience, and good accuracy without oscillation. That's all. Thank you for listening. Is there any questions? I'm ready for answer.
Okay, thank you for presentation.
Thank you.
Is there any question? Okay, next. Dear Hamza.
Hello.
Hello.
Yes.
You can start.
Okay. Can everyone see my screen?
Yeah, no problem.
Sorry. Hello, everyone. Today, the topic of my discussion is development of a torque vectoring strategy to improve performance in electric vehicles with individually driven wheels. Okay. The outline basically comprises of an introduction, a short introduction to torque vectoring systems, the simulation setup, the reference models used, and then the control laws, a higher level controller, and then the proposed control method, which I have used in my studies. Torque vectoring is basically a stability system which distributes the driving or braking forces across an axle or across both the axles to generate a corrective yaw moment. Passive torque vectoring systems rely on only braking, which has its advantages for safety purposes, but it usually degrades the vehicle's longitudinal performances. Whereas an active torque vectoring system does not affect the longitudinal performance in any adverse way, but it increases the longitudinal performance in some cases, and it also generates the required corrective yaw moment. Torque vectoring can be used to maximize performance, and it could be used to increase safety and stability. It can be used to increase the yaw rate acceleration for performance purposes, and it can be used to decrease the yaw rate acceleration for stability purposes. In short, a friction circle represents the maximum available tire force for each tire, and it usually it depends on the coefficient of friction and the normal force. Here we can see for a right-left TV, for a vehicle turning to the left, the weight transfer is towards the right, and this results in an increased friction circle or an increased maximum potential for the right tire. For a longitudinal driving force, if without TV, the longitudinal driving force is similar for both the tires. And here the longitudinal driving force is restricted by the inner tire as it has less potential. Overall, so we can see that the resultant for the inner tire is equal to the longitudinal force. So with TV, this longitudinal force is decreased, and this difference is then added to the outer tire. This results in a resultant which comprises of both lateral forces and longitudinal forces. This increases the generated yaw moment. This can also be applied not only across an axle, but across a vehicle. And this can be applied across a vehicle. This is front rear torque vectoring. In my simulation, I've used a 2 degree of freedom bicycle model as a reference vehicle with linear tire forces, with a linear tire force model, and the yaw rate response is calculated under steady state conditions. The desired yaw rate can be calculated through simple trigonometry and geometry, as the equation states, where KUS is the understeer gradient. The understeer gradient depends on the parameters of a specific vehicle, where A is the distance from the front tire to the center of gravity. This can change according to different vehicles, and for this simulation, we have kept it as a neutral vehicle since it's a reference point. And the main vehicle model, which all the control laws will be applied to, is the planar vehicle. It's a 3 degree of freedom model with only longitudinal, lateral, and yaw dynamics are considered. The pitch, roll, and bob moments are ignored for this. The tire model is a non-linear tire model, and We have also, I've also included weight transfer in it, as it will be involved in the low-level controller calculations. The time model I've chosen is the Dugov time model, as it approximates the tie forces in both linear and non-linear regions. It is, unlike a magic formula, it is a good approximation. It's not a real model per se, but it's a good approximation, and it is used for a fair comparison between different time models, between different low-level controllers. The main strategy here involves the use of a high-level controller, and then this high-level controller generates a desired yaw moment, which can be used to drive the low-level controllers. Sliding mode control is used as a high-level controller for this application. The yaw rate is the only track parameter of the vehicle. The sliding surface is chosen to be the yaw rate minus the reference yaw rate, and the desired corrective moment after equating the sliding surface and differential of it in the vehicle yaw moment equations, we get the following desired moment equation. The proposed control method basically involves a sliding surface controller which outputs a desired yaw moment to the low-level controller, which inputs a yaw rate error, as it will be used to drive the proposed control method, and this eventually drives the time model. The proposed control method involves the use of combination of multiple low-level controllers. This is done to maximize the performance and the stability of a vehicle in different conditions, as certain low-level controllers are perform best in certain conditions, and this controller is run by thresholds. Sorry, this specific controller is run by thresholds. I'm really sorry. This specific controller involves the use of user-defined thresholds, which are basically yaw rate error values, and they are used to switch between different strategies. Mode 1, in mode 1, only the rear axle is driven and the front axle is used for torque vectoring. And mode 2, both axles are provided with corrective torques, as well as the rear axle being driven. This increases the overall performance, as both axles are now involved in the generation of the desired moment. In mode 3, only the rear axle is driven, but this base driver torque is also divided according to the ratio of normal forces. This prioritizes safety, as the base torque, the driver torque is also divided. Longitudinal performance also decreases, but in turn, this increases the lateral performance. The input for this simulation was a sine steering input, and this simulation is run for in two conditions: a standard condition where the coefficient of friction is 1, and in low grip conditions where the coefficient of friction is 0.5. For fair comparison, all the controllers were run at 20 meters per second. This was achieved by using a cruise control, a simple P controller as a cruise controller. In dry road conditions, the yaw rate response is seen here. As we can see, the red line is the experimental proposed controller, and this has the best performance. The next best is the rear wheel drive front torque vector controller, and And as we can see here, the least deviation is in the proposed controller. Same is proved here in the guarded error graph. And if we let the full simulation run its course for 30 seconds, this is the output of the position. This is the output of the position graph, where we can see that the best performance is the proposed controller, followed by the rear wheel drive plus FTV and the forward wheel drive plus RTV. These other controllers are usually used in the literature. These are widely used controllers which are used for comparison here. In low grip conditions, we can see that the proposed controller outperforms every single other controller. The basic and the vehicle with no TV are not able to cope with the conditions. And as you can see here, the other controllers eventually get back to zero. They get back to the resting position. Here from 10 seconds to 11.5 seconds, we can see that the mode 3 is active. This proves that the proposed controller works in extreme conditions better than other controllers, as same is true for the speed graph. Only the proposed controller is able to stick to the 20 meter per second set speed of the we can see here in the position, we can see here for the position graph, the proposed controller has the least deviation compared to other widely used controllers. Thank you.
Thank you for presentation. Is there any question? Thanks again. Next presentation. Dear Fahmet Ali.
Hello. Hello.
Hello. You
Yeah.
can start.
Can you hear me, Evan?
Yeah, no problem. Dear Fahmet. Okay. Dear Saad.
Yes, sir. Can you hear me?
Yeah.
Can I start?
You can start.
Okay. Hello, my name is Asma'Allah Fallaha, and today I will present our work on behalf of my teammates, Saad Al-Karale, Dalek Rahim, and Muhammad Tajuddin, who are here present in this meeting. So our project face mass detection using deep learning for public places. As an introduction, and over the past century, before and after the pandemic of COVID-19, workers in multiple sectors have been required to wear face masks during duty. However, physical 24/7 supervision is mainly impossible. So the solution here is to build a face mask detection that can work automatically. Image classification works by assigning a label or a class to an input image. The problem here is that processing a huge number of images can be difficult. So it is better to use an automatic and effective classifier. Mass detection system has some common steps that can be summarized as the following. preparation of dataset, feature extraction, system classifier, and class assignment. In this study, 4 datasets that are publicly available were used. The first dataset is created by Vijay Kumar. The total number of this dataset approximately 6,000 images. It has 2 categories, image with mask and image without mask. And the image here in this dataset with unified dimension. It is 128 by 128 pixels. The second dataset has image from Google and Jessica Lee self-face. It consists of almost 12,000 images with 2 classes, with mask and without mask. The images here are of different sizes. Whereas the third dataset is a combination of several datasets. The RMFD dataset is a Kaggle dataset which gathered by Bing Search API. It includes 79 images with mask and without mask label. This image here also varies. The last dataset at the previous dataset has 2 categories, with mask and without mask. It consists of 33 images of real people with mask. That means it's not created by artificial intelligence and the image with different dimensions. Pre-preparation of dataset has a second sub-step, which is cleaning up the data. This process will enhance the performance of the whole system. As for feature extraction, it takes raw data and converts it into a format that the computer can understand. This data, secondly, will be normalized in the range between 1 to -1, and lastly, this feature will be saved as a NumPy array. Having a qualified classifier is essential to have a successful process. Here in this session, we will discuss in detail 5 classifiers. The first one is VGG19. It is a convolutional neural network with 19 layers deep. This model was pre-trained using the ImageNet dataset. These datasets contain 14 million images that belonging to approximately 1,000 classes. This model performed well in image classification field. While MobileNet version 2 is also a convolutional neural network, which introduced by Google. It includes 53 layers. This model was also pre-trained using ImageNet dataset, and it offers highly efficient mobile-oriented model used for image recognition. In other words, it introduced to develop the deep learning approach that works on mobile devices. The third model consists of 2 convolutional layers for feature extraction. These 2 conv layers followed by ReLU activation function and max pooling. Also, a dropout, flatten, and 2 dense layers were used. This model was created using Keras. As the previous model, sequential tool model was created sequentially. The model includes 4 convolutional layers. All these conv layers followed by ReLU activation function and max pooling, despite the third layer, which followed by ReLU activation function and dropout layer. In addition, flatten and dropout and 3 dense layers were used. Sequential 3 is the last model. It has 3 convolutional layers, which also followed by ReLU activation function and max pooling. In this model as well, we have 2 dense layers, dropout, and flatten. Class assignment is the last step in mask detection system. The output here is one of 2 classes, either a person with mask or a person without mask. And the used model will predict only one of these 2 classes. Experiment and result. In this session, we will compare the performance of the 5 mentioned model over the 4 datasets. It is worth mentioning that 3-fold cross-validation were used in this experiment. And to ensure the robustness of the result, evaluation metrics such as accuracy, precision, recall, and F-score were utilized as well. This table shows the results of our experiment. So based on the experiment, we can say that all models performed well, but MobileNet version 2 and VTG19 can be considered as the most efficient system. However, MobileNet version 2 outperformed all other models when it comes to low data images. As a conclusion, this study investigates the performance of all mentioned models. The result of all models was pretty good, but MobileNet version 2 and VTG19 achieved the best results ever. However, MobileNet version 2 was able to outperform VTG19 as we discussed before in the case of low quality images. Here's the reference, and for listening and giving us the opportunity to participate in this conference, I would like to thank you, and surely we are welcoming any question.
Thank you for presentation. Is there any question? Okay. Next presentation, dear Fahmet.
Yes. Sorry for before this presentation.
No problem. You can
Okay.
start.
Okay, let me share you my present first. Okay. Okay. Can you see my screen?
Yeah, no problem.
Thank you. Let me start. Okay. Okay. Dear all present participant and research scholars, my warm welcome is to all who are present over here. I'm Fahmid Ali, MS Research Scholar at Istanbul Aydın University, Turkey. First of all, I would like to thank my supervisor, Riza Ilhan, for guiding me the best throughout my research, and I would like to express my gratitude towards the ISS for this conference, for providing me the opportunity to present my research work in front of you all. As it is going well successfully in its 6th International E-Conference, I'm happy and lucky being a part of this beautiful platform for the researchers. Okay, the title of my research paper is developing a guided tactile feedback system for blind people. Okay, here is the content of my presentation. In this, I will present this topic moving now towards the introduction. Okay. The introduction. For those who are blind, haptic interfaces are becoming more advanced. This study aims to provide blind persons with the necessary rehabilitation so they participate in their favorite sports. In order to guide the user's hand on the court, wearable haptic feedback glove that is integrated with a robotic arm is described in this study, along with its design, operation, and implementation. Okay. The glove is cheap, light, and equipped with coin vibration motors that provide vibratory input that characterizes the ball's path. On 5 people, the system was tested. The test was psychological and physical. The system received favorable comments from the participants, and they had a pleasant overall experience. The system simplicity of use led them to suggest it. The lack of surface details, including texture, shape, and graphical elements, while a person is touching a display, such as one on a smartphone, is a typical issue for those with visual impairments. For the purpose of creating tactile information, they were employing electrovibration. Volleyball game. Let me introduce or explain you all about the volleyball game. In this, around 2,000 million people worldwide are reportedly volleyball players. 2 teams of players may play volleyball on a court that is 18-meter long and 9-meter broad. The court is evenly divided into 2 hallways by a net is 2.43 meters high for men and 2.24 meter high for women, which is painted in black on the court floor. In the middle, there are two teams playing the game, and each team consists of 6 players. In the beginning, one player from each team throws the ball from the court edge and strike it with their hand or arm. The opposing side must prevent the ball from touching the ground. To hit the ball back the other side, the players should try to avoid touching it more than 3 times. No one on the team may touch the ball twice in a succession. In the first 4 games, known as sets, a side typically required 25 points to win and 15 in the fifth. Why we choose game? Out of the world's 7.79 billion people, there are an estimated 49.1 million individuals who are blind or visually impaired. Another common issue for these folks is in navigation. Even average individuals in today's congested, complex world must employ assistive technology to avoid hazards and navigate their way through it. People are deaf, deaf, and blind, in particular, require a firm to hand act out the game for them. Rarely have scientists discuss this topic. The most pretend study was the creation of foot bride, which enable blind and impaired individual to watch football. Users may lay their hands on a carpeted gadget that resembles a saucer pitch to utilize football. Foot bride. A little ball, that moves in the time with the game during play makes it simple for supporters to keep track of game statistics. By considering all these points, a haptic glove was created for watching a football. The haptic gloves enable signals to be received and vibration to be produced in the hand, providing information about a situation. The participants' response to the questions demonstrated that they approved of the system. Okay. Here's components. Uh, so here is the list of some main components that play a very important role in creating my project. So let me tell you how Arduino work in creating my project. The haptic glove has vibration motors that resemble coin at the tip of the finger, and those vibration motors running in the length of the middle finger. For control, an Arduino connection is made between the motors and other components. Next, a servo motor MG996R. This is a metal gear servo motor with a maximum stall torque of 16 kg per centimeter. Is the MG996R. This motor performs a rotation roll from 0 to 180 degree. A small size coin vibration motor. Coin vibration motor is used to provide the vibratory feedback which describe the direction of the ball. Last, aluminum plate. Two aluminum plate with diameter of 70 mm and 50 mm and 2 mm thickness were used to create the two links of the robotic arm. Design of the court. Moving further, the design of this court was imagined to be a rectangular area with 90 centimeter height and 180 centimeter width. As you can see clearly in this given picture, image, that our starting point is in the center. It was split in half. The net position is shown by this line. Sorry, this line you can see. two teams of players were formed. We have given them an identity with a name of team A and team B, where the team's name basically volleyball teams typically include 6 players. But for the sake of this study, it was imagined that each team would have 4 players, with one player designated to provide service. This is TA5. This is uh, designated to provide services. The position and angle of the players were chosen at random. Structure of robotic arm. As you can see in this experiment, the user's hand was guided by the robotic arm in accordance with the placement of the ball. For the construction of robotic arm, we need two aluminum plate with length measuring 70 this and 50 this, and 2 is thickness that were used to make the two-link arm. Those two joints each house a pair of MG996R servo motors with maximum stall torque of 11 kg per centimeter and metal gears. Well, we using screw, the system was tightly fastened to the foundation. It can be clearly shown in given figure that illustrate the arm, which is a linear chain with two rotatory joints. The length of the two links are L1 and L2 respectively, and the angles at which the two joints can rotate are respectively 1 and 2. Initially, a SolidWorks software was used to create the arm angles for all game related occurrences. By continuing this topic here, I would like to tell you a point that SolidWorks was only used to gather information on angles for every game action. However, the further information like forward kinematics and inverse kinematics might be used to create an automatic system. Haptic gloves. Wearable haptic glove has the potential to become a vital tool for improving the sensory experience for persons who are blind or visually impaired while watching volleyball. This is shown with a haptic glove and robotic arm. Furthermore, the suggested technology may be expanded to depict additional games. The cloth used to make the glove may be altered to accommodate various hand size by varying the length of each finger's appendage to simulate a genuine hand. On the interior pair of the gloves are the cable and haptic motors to offer tactile feedback. 9 miniature low-power coin vibration motor were employed. Team B is represented by TB, uh, TB1, TB2, TB3, and TB5. Whereas Team A is represented by TA, is TA1, TA2, TA3, and TA5. The final, uh, the final one, which served as an auxiliary, was situated on the back of the hand. Guys, for for the right hand functioning prototype was created first, and Arduino Uno was used to manage the entire setup. Algorithm for working haptic gloves. As previously mentioned, there are rules and occurrences in the volleyball game, such as fouls, timeouts, service, etc. The following algorithm was taken into consideration in order to construct all effective events prior to each event. The time window was established to provide participants adequate time to pay attention and comprehend. Here let yes, comprehend. Sorry. Here, let me explain you the working of my work. There is a 5-second delay before the game beginning for setup. A service initiates the game V5 vibrate as a service for 1 second. Each vibration motor startup. The V5 goal vibrates for 1 second once a goal is scored. The mutual motors TB1, TA1, TB2, TB2, TA2, and TB3 and TA3 vibrate synchronously while a goal is being attacked or defended. The goal function becomes active when a team scores a point. The regular game continues if no team earns a point. The referee ends the game if a foul is committed, for example, touching the net. In this instance, V1, V3, and V5 vibrate at the same time twice for 0.5 seconds. The goal function is then turned on. V5 vibrates twice for 2 seconds if one team's service hits the net. The goal feature for the opposing team is then activated. Both V5 are vibrated for 2 seconds to signal timeout. No function is activated during a timeout. V1, V2, and V3 vibrate constantly if a team misses the ball, i.e., it lands outside the court. The goal feature for the opposing team is then activated. V1, V2, V3, and V5 vibrate twice for 0.5 seconds if a team wins a set. Actually, V is the collective word for any player on any scout. Experimental analysis. User research was conducted to assess the effectiveness of the suggested solution. Following the signing of a written form agreement for male and 1 female volunteer, mean age 25, age range like 10 to 30 years, participated in the study. None of the participants had ever tested a system like this before. The process was authorized by Istanbul Aydın University. A sample volleyball match between Japan and France men's volleyball World Grand Champions Cup in 2017 was chosen to test the technology. The first 3 minutes worth of events were all retrieved and coded using the previously mentioned method. There were 26 occurrences in all that were retrieved, including fouls and timeout. Each user heard the computer game being played as given random occurrences were performed for them. On the given figure, uh, you can see finished system. There is a finished system, and the person see the person touches the robotic arm with his hand. It directs the hand of the user to the appropriate location. Yeah. They were afterwards asked to comment on whether they could feel the associated incident. Figure display the result of the experiment. When the user places his hand on the arm directs the user hand in accordance with the location of the ball. Figure shows as such incident starting service for the game coming from A5. Here it is, you can see. The initial ball is received by TB1, who then send it to TB3. Here is TB3, and TB2, you see here, TB2 spikes the ball to finish, and TA3 is simultaneously making a defense, but team B earned a point as a consequence, which resulted in the activation of TB5 goal. Result and discussion. Throughout the game, the player responded to a few questions on their experiences. Each question was followed by a Likert scale response that ranged from 1 to 7. The lowest score is 1 and the highest score is 7. Table presents the outcomes. The majority of participants, as shown in table, were happy with with the experiment, and throughout it was integrating to attempt. However, the vibration strength and kind received the lowest mark, indicating that they need to be improved. The ability to recall the complete incident also needs training. According to some users, they require some time before each event, which may be due to memorization and interpretation. They were happy with the experiment overall and had fun playing the game with a new technology. Hence, this table outlining the result of a survey based on questions. This. See? The conclusion. The goal of this study was to develop a system that was affordable, lightweight, portable, and user-friendly for patients. The ARM was first created using the SolidWorks software, and all motion data was gathered. The pitch is standard measurements were 90 by 180 centimeter. Player positions and angles were predetermined. The complete game events were retrieved and programmed in accordance with the methodology using sample game that was chosen. A psychophysical experiment was used to gauge the system effectiveness. The results show that the participant skills in use sorry, using the haptic glove and actively participating in the game considerably increased. Additionally, several of the participants said that the system may be enhanced by including more elements, including different directional sound effects to foster a positive environment. Some of them thought were content with the way things were just now. Additionally, they commented that also the suggested solution is economical. It has to be readily available in the marketplaces. Future work. Numerous researchers have attempted to improve the lives of people who are blind in order to help them feel happy despite their impairments. Uh, and additional research is still being done in this area. As technology develops, additional options may be included into system. The participants found the current suggested design to be suitable and user-friendly. It was found that adding a camera and virtual world to the system, to the system would increase the participant enjoyment. Okay. Here is a video we are to experiment for. Let me play it. And I hope my work and its result will be very much beneficial to society. Thank you so much.
Thank you for presentation.
Thank you.
Is there any question? Okay. Dear Dala,
Yes, I'm here.
yeah, you can start.
Screen, okay. Can you see my screen?
Yeah.
Okay. So this is Dala Krayem speaking. My colleagues Saad Al-Qarare, Dalek Rayem, Asma'ullah Fallaha, Muhammad Tajuddin Ashur are attending this conference with us today. And we would like to thank you for taking the time to listen to our presentation. This study is about CNN hyperparameters optimization using random search for image classification. CNN and deep learning have excelled in nearly all computer-based systems over the past few years, especially in text, images, and video-based classification. CNN models that require a lot of time and expertise, and it gets better or worse depending on these parameters. Some of these parameters are the size of filters, the number of filters, the dense rate, and the dropout value. These all have an essential effect on the overall performance of the CNN model. CNN hyperparameters, as we discussed, are a big part of our system, and we investigated the differences it instigates. Hyperparameters are values or variables that directly affect the learning rate and the structure of the network and are set before training. And some of these hyperparameters used are as follows, but not in order. We have dropout value, dense rate, the size of the filters, and the number of the filters. For dropout value, this is a regularization technique used to prevent overfitting. Overfitting is actually improving validation accuracy, hence boosting the generalization power. For dense rate, this is the number of neurons used in the layer. And for the size of the filters, this is referred to as kernel size and are expressed by n. These values are interchangeable and increase or decrease the width and the depth of the network. So here by n, we mean it could be 1 by 1, it could be 3 by 3, or 5 by 5, depending on what you choose. For the number of filters, using more filters can actually affect it does not increase the performance, rather it risks overfitting due to the increase in parameter count. Because we are investigating classification, we first need to know what image classification is and what the steps of it are. Image classification is assigning a label to an image, giving it context. And as mentioned here, these steps are the selection of data, the data preprocessing, feature extraction, system classifier, and lastly, classification output. We first need to select the data. We need a specific data depending on our system, and this is the most crucial step in any system. The data set we worked with is actually a combination of 4 data sets, and this data set consists of 2 classes that are decided on beforehand. As I mentioned, we have a data set that is combined using 4 other data sets. The first one contains 6,000 images, the second one contains 12,000 images, the third one 4,000 images, and again, the last one, which is called the FMD data set, also contains 4,000 images. Next, after taking the data, we need to pre-process it. This step takes raw data and replaces it into a format that computers can comprehend. The data here is pre-processed by OpenCV, which is a feature-rich computer vision software that is important to pre-process this data that we took. After pre-processing the data, we need to take the features from the images. So this step is called feature extraction. And in this step, features are extracted by finding distinctive features from the input images. And the array that is generated during the pre-processing is normalized to a range of -1 to 1 and is kept in a single NumPy array. And after that, we need a system classifier. To have a successful classification procedure, we need a classifier that is specific to the system. And here we discuss the effectiveness of 2 cutting-edge CNN-based mass detectors. These models are VGG19 and MobileNet version 2. VGG19 contains 19 layers with 3 fully connected layers for classification, 16 convolutional layers for feature extraction. Then each convolutional layer is followed by 5 max pooling layers and 1 soft max layer. And this is based on the ImageNet dataset. As for MobileNet version 2, this is created to provide the opportunity to build computationally low-powered deep learning models for mobile-related systems. MobileNet version 2 is a productive extraction tool for mobile. And lastly, we have the classification output. This step provides a category where each input falls into. We can understand that the model anticipates one output for each image. And here we have our experiment and our results. We compared MobileNet version 2 with VGG19 using accuracy, F1, precision, recall, and using random search like we discussed that this study is based on. This table was before using the parameters. We can notice the numbers here are good, but after using the tuning parameters, we can notice a difference in the results. For accuracy in VGG19, the improvement was 1.97%, while in MobileNet version 2, it came up to be an increase in 7.55%. For the F1 part, VGG19 came up to 1.87%, and again 7.55 in MobileNet version 2. Precision in VGG19 improved to 1.88%, and in MobileNet version 2 to 7.56%. And lastly, but not least, the increase for recall in VGG19 was 1.87% and 7.55 in MobileNet version 2. From these results, we can notice that MobileNet version 2 achieved better results. By comparing these two tables, we observe that using random search has significantly improved the performance of both used models. In other words, the finding of the study demonstrated that applying the hyperparameter optimization strategy enhanced the model's overall performance, and especially gave a push in MobileNet version 2. In conclusion, the study examined the effects of CNN hyperparameter optimization, and from the conducted experiments, we can observe that the hyperparameter optimization technique enhanced the performance of the models. Thank you so much for listening to our presentation, and I welcome any questions if you guys have any.
Thank you for presentation. Is there any question? Next presentation, dear Serdar Artem.
Merhabalar.
Merhabalar. Hazırsanız başlayabilirsiniz.
Hazırım. Teşekkür ederim. Merhabalar, sesim geliyor mu?
Evet, geliyor.
Ekran paylaşımı için
Ekran paylaşımı yaptığında bilgisayar ses paylaşımını kapatırsanız mikrofonunuz aktif olur.
şu an ekran paylaşımı yapabiliyorum değil mi?
Yetkiniz var.
Ekranı paylaş diyorum da şu an. Sistem sesini paylaşacak mıyım, kapatacak mıyım?
Sistem sesine gerek yok. Sadece ekran yeterli.
Şu an ekranım görünüyor mu?
Geldi, problem yok.
Teşekkür ederim. Merhabalar, ismim Serdar Erten. Fırat Üniversitesi Bilgisayar Mühendisliği Anabilim Dalı'nda tezi yüksek lisans yapmaktayım. Bu sunumumuzda, daha doğrusu bu çalışmamızda sınıflandırma probleminde derin özellik birleştirme yaklaşımıyla domates yaprağı görüntülerinde hastalık tespitini yaptık. Domates yaşadığımız coğrafya ve dünyanın birçok yerinde üretimi yapılan ve en çok tüketilen önemli sebze türlerindendir. Üretiminde ve verim kaliteyi olumsuz yönde etkileyen en önemli faktörlerin başında zararlı organizma olarak adlandırılan hastalık gelmektedir. Çevresel ve iklim faktörlerine bağlı olarak ekim sürecinin her aşamasında birçok hastalığa yakalanabilir. Bitki hastalıklarında yapılması gereken ilk şey hastalığın doğru tespit edilmesi ve gereken önlemlerin alınmasıdır. Bu çalışmamızda 9 hastalıklı bir sağlıklı sınıftan oluşan toplam 18.160 domates yaprağı görüntüsü bulunan veri seti kullanılmıştır. Bu veri setine de genel erişime açık Kaggle domates yaprağı hastalığı veri seti üzerinde deneysel sonuçlar elde edilmiştir. Analizler yapılırken %80 eğitim ve %20 test verisi olarak ayrılmıştır. Yine çalışmada evrişimli sinir ağı tabanlı DenseNet, ResNet 101, ShapunNet modelleri kullanılarak domates yaprağı görüntülerinden toplam 3000 adet öz nitelik çıkartılmıştır. Bunun nedeni aslında birçok mimari kullanıldı. İlerleyen bölümlerde bahsedeceğiz. Bu 3 mimarideki başarı oranı yüksek olduğu için bunlar kullanıldı. Ayrıca bu çalışmada öz nitelik sayısını düşürmek için temel bileşen analizi kullanılarak boyut indirgeme yapılmıştır. Domates yaprağındaki hastalıkları sınıflandırmak amacıyla destek vektör makineleri algoritması kullanılmıştır. Eğitilen ağ mimarileri tek tek incelenmiştir. Bu incelemeler sonucunda mimarilerin doğruluk oranları AlexNet %93.5, DenseNet 201 %97.1, GoogleNet %97.1, MobileNet %91, ResNet %94.5, özür dilerim, %97.4, ShapunNet %96.6 bulunmuştur. Yapılan analizlerden sonra doğruluk oranı en yüksek olan DenseNet 201, ResNet 101 ve ShapunNet ön eğitimli ağ mimarileri birleştirilerek ve temel bileşen analizi kullanılarak boyut indirgeme yapılmıştır. Bu çalışmada yapılan sınıflandırma analizlerine göre en yüksek performans gösteren QUIC destek vektör makinesi sınıflandırıcısı ve One VSO çok sınıflı bileşen metodu ile %99.2 doğruluk oranına ulaşılmıştır. Literatür incelemeleri sonucunda domates yaprağı hastalık tespiti için bu çalışmanın etkili ve yüksek bir performans gösterdiği sonucuna ulaşılmıştır. Bitki üreticileri bu hastalıkları bilebilir fakat tanımlaması güçtür. Hastalığı bilse bile bu hastalığı tedavi etmek için uygulaması gereken metotlar hakkında bilgisi olmayabilir. Teknolojinin ilerlemesiyle birlikte yapay zeka uygulamaları zirai alanda hastalığın tespiti ve bitki türü sınıflandırmasında da rol almaya başlamıştır. Yapay zeka metotları güvenilirliği yüksek ve seri sınıflandırma yapabilmesinden dolayı hem zamanı verimli kullanmayı sağlar hem de iş yoğunluğunu azaltması açısından avantaj sağlamaktadır. Yine yapılan literatür taramalarında Çenk ve arkadaşları tarımsal zararları tanımlamak için ResNet ve AlexNet kullanmışlardır. Aynı zamanda destek vektör makineleri ve geri yayılım sinir ağları ile karşılaştırmalı deneyler yapmışlar. Sonuçta ResNet 101 tarafından %98.67'lik en iyi doğruluğu elde etmişlerdir. Yine farklı bir çalışmada Liu ve arkadaşları 13.689 resimden ve 4 sınıftan oluşan çalışmalarında AlexNet ve GoogleNet metotları ile %97.92 doğruluk oranı sonucuna ulaşmışlardır. Farklı bir çalışmada 139.011 görüntü ve 42 sınıf olan veri setine AlexNet ve Y19, Inception, DenseNet 201 ve ResNet 152 mimarilerini uygulayarak %93.67 doğruluk oranı sonucunu bulmuşlardır. Cheng ve Madsen ot ve pirinci tanımlamak için karar ağacı, destek vektör makinesi ve sinir ağı kullanılarak elde ettikleri en iyi doğruluk %98.2 olmuştur. Çalışma ile ilgili literatür taraması yapılmış, yapılan analizler ve elde edilen sonuçlar hakkında bilgiler verilmiştir. Bu çalışmada yaygın olarak kullanılan evrişimli sinir ağı tabanlı AlexNet, DenseNet 201, GoogleNet, MobileNet, ResNet 101 ve ShapunNet kullanılmıştır. Yine analizlerden sonra doğruluk oranı yüksek olan bu 3 mimari DenseNet 201, ResNet 101 ve ShapunNet ön eğitimli ağ mimarileri birleştirilmiştir. Veri setimizde kullanılan görüntüler 24 bit derinliğe sahip ve özellik çıkarımı yapılmıştır. Elde edilen özelliklere temel bileşen analizi ile boyut indirgeme tekniği uygulanmıştır. Daha sonra makine öğrenmesi sınıflandırıcılarından kübik destek vektör makinesi ve One vs All sınıflandırma yöntemiyle optimize edilerek domates yaprakları hasatları tespit edilmiştir. Bu bölümde çalışmada kullanılan veri seti, CNN mimarileri, temel bileşen analizi ve makine öğrenme sınıflandırmalar yöntemleri incelenmiştir. Bu çalışmada kullanılan yöntemin akış diyagramı şekil 1'de verilmiştir. Veri setimizde bulunan görüntüler ilk önce bahsettiğimiz 6 mimaride denenmiş. Sonra işte öz nitelik ve picture'lar birleştirilmiş. Birçok sınıflandırma yöntemi kullanarak doğruluk oranı en yüksek olan küp destek vektör makinesi kullanılmıştır. Daha sonra bu mimariler içerisinde en yüksek doğruluk oranına sahip olan DenseNet 201 ve ResNet 101 ShuffleNet kullanılmıştır. Buradaki bu üç mimariyi görmemizin nedeni en yüksek doğruluk oranına sahip bu üç mimari olduğu için. Yine özellik çıkarımı olarak Fully Connected katmanda çıkışlarımız çıkış sayısını belirledik. Default olarak her birinden biner öz nitelik çıkarımı yapılmıştır. Toplamda bu biner öz nitelik birleştirilmiş. Bu boyut indirgeme yöntemiyle tabii çeşitli değerler denenerek en yüksek doğruluk oranına sahip olduğumuz 1500 öz nitelik kullanılmıştır. Yine dediğimiz gibi kübik destek vektör makinesi kullanmamızın nedeni yaptığımız analizler sonucunda en yüksek doğruluğa sahip olduğu için bu sınıflandırıcıyı kullandık. Yine multiclass metot olarak da One vs All kullanıldı. Boyut indirgemeden sonra doğruluk oranına, bahsettiğimiz doğruluk oranına ulaşıldı. Yani burada aslında çalışmamızda önerilen yaklaşımın akış diyagramını görmekteyiz. Öz nitelik çıkartma işleminde yapısal olmayan verilerde öz nitelik çıkarma işlemi yapmak için bu verilerin matematiksel formda yapılara, yani nümerik değerlere dönüşülmesi gerekmektedir. Özellik çıkarımı işlemlerini gerçekleştirebilmek için öncelikle yapısal olmayan veriler algoritmalar tarafından anlaşılabilecek temsillere dönüştürülür. Daha sonra özellik çıkarımı işlemleri yapılır. Çeşitli metotlarla görsellerdeki özellikleri çıkaran ve onları sınıflandıran evrişimli sinir ağı mimarileri farklı katmanlardan oluşmaktadır. Bu mimariler ile etkili ve verimli sonuçlar alınabilir. Evrişimli sinir ağlarına biraz bahsedecek olursak, evrişimli sinir ağları çok katmanlı algılayıcıların bir türüdür. En etkili ve doğruluk oranı yüksek sonuçlar alındığı için özellikle görüntü işleme alanında daha çok kullanılmaktadır. CNN mimarileri ile görüntüler üzerinde hız ve doğruluk oranı yüksek sonuçlarla sınıflandırma işlemi yapılmaktadır. CNN mimarilerinde bulunan temel katmanlar giriş, evrişim katmanı, havzama katmanı ve sınıflandırma katmanıdır. Mimari birleştirmeden biraz bahsedecek olursak, CNN modellerinden DenseNet 201, ResNet 101 ve ShuffleNet ön eğitimli ağ mimarileri kullanılarak 18.160 domates yaprağı görüntüsünden 3000 tane öz nitelik çıkartılmıştır. Elde edilen öz nitelikler MATLAB 2021 versiyonu uygulamasında birleştirip karma, hibrit bir evrişimli sinir ağ modeli oluşturulmuştur. Şekil 2'de mimariyle birleştirildikten sonraki veri seti, sınıf dağılımı ve sınıflar gösterilmiştir. PCI metodu büyük boyutlu bir veri setini daha düşük boyutlu bir veri seti haline getirir. Bu yöntemde en büyük öz değere sahip olandan en düşük öz değere sahip olana doğru sıralanır. İstenilen değişimi yakalayan sayıda öz vektör seçildikten sonra bir doğrusal dönüşüm yapılır. Bu çalışmada elde edilen hibrit evrişimli sinir ağ mimarisi ile öz nitelikleri çıkartılmış domates yaprağı görüntülerine temel bileşen analizi tekniği uygulanmıştır. 18.160 görüntüden 3.000 öz nitelik çıkartılmışken PCI yöntemi uygulandıktan sonra doğruluk oranı en yüksek sonuç alındığı gözlemlenen 1500 öz nitelik boyutuna indirgenmiştir. Ön işleme ve özellik çıkartma adımları bittikten sonra görüntülerin sınıflandırılması destek vektör makinesi sınıflandırıcısı tarafından gerçekleştirilir. Destek vektör makinesi sınıflandırıcısının eğitimi matris formunda depolanan özellik vektörler alınarak yapılmıştır. Hibrit CNN destek vektör makinesi modelinde Otomatik oluşturulan özellikler el yazısı basamak veri kümesine eğitmek ve test etmek için destek vektör makinesi modülüne aktarılır. Mühendis test verileri benzer şekilde önceden işlenir ve daha sonra sınıflandırıcı test etmek için kullanılır. Kübik destek vektör makinesi mesela bu sünnetçi ve arkadaşlarının yaptığı çalışmada 137 COVID-19, 90 normal ve 90 pneumonik kişilerden alınan görüntülerden oluşan veri seti üzerinde AlexNet CNN mimarisi kullanılmış. Her görüntü için 1000 özelliği çıkartılmıştır. Kübik destek vektör makinesi sınıflandırıcı kullanarak %95.27 doğruluk elde etmişlerdir. Biz kendi çalışmamızda domates yaprakları hastalıkların tespiti ve sınıflandırılması için diğer sınıflandırıcı yöntemleri sonuçları gözlemlenmiş ve en başarılı doğruluk sonucu alınan kübik destek vektör makinesi sınıflandırıcısı ve VROOM2 multiclass metodu tekniği kullanılmıştır. Veri setinden bahsedecek olursak bu çalışmada 9 hastalıklı ve 1 sağlıklı sınıftan oluşan 18.160 domates yaprağı görüntüsü bulunan veri seti kullanılmıştır. Genel erişime açık Kegel domates yaprağı hastalığı veri setinde bulunan görüntüler şekil 3'te 2 gibidir. Ayrıca veri setinde bulunan sınıflara ait görüntü sayıları ve hastalık tipi tablo 1'de verilmiştir. Hastalıklar ve sınıflar, burada sınıfların renklendirilmesi MATLAB'da ayırt etmek için ve her bir sınıfa ait görüntü örnekleri şekil 3'te bulunmaktadır. Model performans değerlendirme metrikleri olarak CNN mimarileriyle eğitilen veri setlerinin doğru sınıflandırma oranını hesaplamak için karmaşık bir matris kullanılır. Hata matrisi de diyebiliriz. Hata matrisinde tahmin edilen ve gerçek değerlerin gerçek pozitif, yanlış pozitif, yanlış negatif ve gerçek negatif parametreleri verilir. Doğruluk, duyarlılık, kesinlik ve F-score bu parametrelerle elde edilir. Sınıflandırma doğruluk oranları tablo 2'de gösterilen hata matrisinde belirtilen ölçümlerle hesaplanmaktadır. Oluşturulan model üzerinde yapılan sınıflandırma performansını belirlemek için hata matrisi kullanarak metrikler aşağıdaki denklemlerden hesaplanır. Yine sınıflandırma problemleri için en önemli diğer performans metriği olan ROC eğrisi. ROC eğrisinde hatasız olan incelemede eğri 0'a 0, 0'a 1 ve 1'e 1 noktalarından geçer. En hatalı ROC eğrisi 0'a 0 ve 1'e 1 noktalarından geçer. Bu iki eğriye göre değerlendirmeler yapılır. True pozitif yani gerçek pozitif değerinin yanlış pozitif değerine oranı ROC eğri grafiğini göstermektedir. ROC eğrisinin altında kalan alan AUC değerini verir. Bu değerin 0'dan 1'e doğru yaklaşması pozitif değerlerin negatif değerlerden başarılı bir şekilde ayrıldığı anlamına gelir. Deneysel sonuç ve tartışma kısmında öncelikle genel erişime açık Kegel domates yaprağı görüntülerinden oluşan veri seti üzerinde AlexNet, DenseNet 201, GoogleNet, MobileNet, ResNet 101 ve ShuffleNet CNN mimariler uygulanmıştır. CNN mimariler uygulanmıştır. Her bir model için biner öz nitelik elde edilmiştir. Tablo 3'te AlexNet, DenseNet 201, GoogleNet, MobileNet, ResNet 101 ve ShuffleNet CNN mimarileri sınıflandırma doğruluk oranları analiz edilmiştir. Her bir mimaride doğruluk oranı en yüksek sınıflandırıcının kübik destek vektör makinesi olduğu gözlemlenmiştir. Daha sonra domates yaprağı hastalıklarına sınıflandırılması için materyal ve metot bölümünde belirtilen veri seti üzerinde en yüksek doğruluk oranına sahip olan DenseNet 201, ResNet 101 ve ShuffleNet ön eğitimli ağ mimariler birleştirilerek uygulandıktan sonra temel bileşen analizi, kübik destek vektör makinesi sınıflandırıcısı ve VROOM2 çok sınıflı bileşen yöntemler uygulanmıştır. Bu çalışmada ayrıca 10 katlı çapraz doğrulama yani cross validation yöntemi ile gerçekleştirilmiştir. Bahsedilen tablo 3 ekranda görülmektedir. Her bir mimarinin kübik destek vektör makinesi sınıflandırıcısı ile elde edilen doğruluk oranları verilmiştir. Doğruluk oranı en yüksek olan 3 mimari modelleri birleştirilerek uygulanmış ve bu mimarilerin 3000 öz nitelik çıkarılmış ve veri seti oluşturulmuştur. Bu veri setine ait karmaşıklık matrisi ekranda görülmektedir şekil 4'te. Yine ROC eğrisi de şekil 5'teki gibidir. Veri setine temel bileşen analizi ile boyut indirgemesi yapılarak öz nitelik sayısı 1500'e indirilmiştir. Bu 1500 sayısı tabii ki çeşitli analizlerden sonra belirlendi. En başarılı sonucu bu sayıda aldığımız için, öz nitelik sayısında aldığımız için bunu kullandık. Yapılan analizlere göre mimarlar üzerinde doğruluk oranı en yüksek çıkan yine bahsettiğimiz küçük destek vektör makine sınıflandırıcısı ve çok sınıflı bileşen metodu uygulanarak %99.2 doğruluk oranına ulaşılmıştır. Yine şekil 6'da önerilen yöntemin karmaşık matrisi ve şekil 7'de önerilen modelin gerçek pozitif ve yanlış negatif oranları verilmiştir. Tablo 4'te ise bahsettiğimiz modelin öz nitelik sayısına göre ve kübik destek vektör makinesine göre her bir sınıfın doğruluk oranı, kesinlik, duyarlılık ve F-score değerleri görülmektedir. Yine önerilen modelin sınıflara göre ROC eğrileri de tek tek çalışmada belirtilmiş ve gösterilmiştir. Şekilde görüldüğü gibi. Sonuç olarak bu çalışmada domates yaprağı hastalıklarının etkili bir şekilde tespit edilebilmesi için kübik destek vektör makinesi algoritması ve çok sınıflı bileşen metodu kullanılarak sınıflandırma doğruluğunun artırılması amaçlanmıştır. Bu kapsamda evrişimli sinir ağı mimarisinden doğruluk oranı en yüksek olan 3 mimari, yani Densenet 201, Resnet 101 ve Shufflenet mimarileri kullanılarak domates yaprağı görüntülerinden sınıflandırmada kullanılacak öz nitelikler elde edilmiştir. Elde edilen bu öz nitelikler temel bileşen analizi yöntemiyle boyut azaltma işlemi yapılarak en yüksek doğruluk oranı elde edilmiştir. Materyal ve yöntem bölümünde bahsedilen mimariler tek tek incelendiğinde en yüksek doğruluk oranı %97.4 iken önerilen yöntemle doğruluk oranı %99.2 olmuştur. Yine yapılan analizler sonucunda kübik destek vektör makine sınıflandırıcısının doğru parametreler ve optimizasyon yardımıyla yüksek sınıflandırma doğruluğuna ulaştığı görülmektedir. Ayrıca boyut indirgeme metodu ile maliyet ve zamandan tasarruf edildiği görülmüştür. Bu çalışmada önerilen modelin domates yaprağı hastalıklarının tespit ve sınıflandırılmasına önemli bir yeri ve etkili bir yöntem olduğu söylenilebilir. Beni dinlediğiniz için teşekkür ederim. Sorular varsa alabilirim.
Evet, sunum için teşekkürler. Is there any question? Next presentation, dear Sharik Ahmet.
Hello.
Hello.
Sharing my screen.
Yeah.
Okay. Hello, everyone. Today, my topic for the discussion here is the smart V2G power transfer on scenario-based strategies trained through ANN for the maximum tariff saving and the energy management. The outline goes, we'll first discuss like why and what are the purpose for this paper and why do we exactly need it. And then we go towards the introduction part and then the methodology as a results. So it goes like this. So first of all, let's say why do we need this paper? It all goes from the basic requirement that in coming future, electric vehicles are the basic part, going to be a basic necessity. Where Volkswagen says that 2030 they are not going to make combustion engine. Similarly, the Ford goes with the 2035 plan, the Honda goes with the 2035 plan. So what's next? We have to go towards the electric vehicles, and what can we do to capitalize and maximize the effects from that? So that's where this paper comes in, and this paper not just basically uses the concept of electric vehicles, but gives some concept for a consumer to get something back. So that comes the V2G, the vehicle to grid power transfer. So that's why we need this paper, and the effects of this paper basically proposes for the, as mentioned in the name, the strategies that are going to make for the maximum tariff saving that comes for the consumer end, and the energy management that comes for the power provider. So for both sides, they have all the pluses we are going to discuss in this paper. And what's the urgency? The Energy Commission, the Energy Agency, the IEA recently publishes in this 2022 article about like there is a very slow growth for the like 6% with the renewable side. So the urgency leads with, if we don't work on this right now, in coming days, there is a higher possibility for blackouts. We'll go further, and we'll discuss that part in the introduction and further. So if coming towards the renewable sources and its importance with in our current environment, we are living in a society where we are mostly consuming electricity, natural gas, and it all comes down towards the fossil fuels and the production of the CO2 gases in our environment. Renewable sources, including solar, wind, they are adaptable. We are using them, we are implementing them, but not at the very much scale. So, and how to capitalize it? For example, the sun is up in the morning, and you generate solar energy for like 5 megawatts, and you use it like maybe 3 megawatts. What happens to the other two? Even though if you just planted all the solar panels throughout the desert. So to capitalize that, we need to have some sources to store it, and that's where we don't need to go towards another source of battery backups and all this stuff. We are going to utilize them just from our cars that we are using for our mobility in an everyday life. The utilization of power in bidirection, and so that combines with you are purchasing electricity and you are giving it back to the grid, and these kind of methods have been involved in various schemes, which goes from grid to vehicle, the vehicle to grid, then vehicle to house. Just house, you can operate your house, for example, if it's in a remote location, then vehicle to directly to the load. These are multiple schemes, but for this paper's sake, we are just going to focus on the V2G. Okay, so coming towards the benefits of V2G, it's the cost effectiveness. For this, in this paper, we provide a smart algorithm which makes the user, the consumer of a car, to return his stored supply to the grid, back to the grid, at the time where cost is varied to the higher part. For example, he purchased an electricity in the early morning at 5 liras, and at night it goes towards 12 liras in the peak hours. So what should we do? He doesn't need that power right now. So what do we do? Okay, let's sell it back. So when he get that back, that's the benefit. That's a plus sign. That's a plus. The big dollars, the big numbers in his tariff is coming up. So he will be like, okay, that's fine. That's fine for me. So then, secondly, it's the major part that's for which the electricity providers are also, and the governments are also, subsidizing these concepts and also promoting this, is because of the grid frequency regulation. That's the more technical part. So what happened is, if the grid supply is higher than the consumption, what happened is, in there is a formula for the slip of a motor. There's a generator on the back somewhere in the generation side. So when the mechanical speed of that motor, it increases because of less load on it. So what happened is, the frequency goes up. The frequency has started going up. So that rise in frequency, here you can see that rise in frequency from the normal range makes disturbances and can even cause blackouts. Similarly, if it goes under, for example, your regular frequency is 50 hertz, but if in your area, if in your grid system, there is a higher requirement of the load, and that will happen. That will happen when electric vehicles are coming in. They are charging for like 200 kilowatts. The maximum charge is 65 kilowatts. So what will happen? The demand will rise, and that can cause this dip in the frequency, and that needs to be regulated. So how come these electric vehicles, this vehicle to grid power transformation, it can assist in this? It can provide a backup supply. Like, when there is a peak hours, the power companies are building an infrastructure where they provide an extra additive for the vehicles who are supplying and the power back to the grid. So, and that goes from one vehicle to the fleets and then clusters. So that's a big infrastructure for which the whole workout to the is also in progress, and a lot of papers have been written on that too. So effectiveness and utilization of renewable energies, as I mentioned earlier, if the energy is generated in the morning, then what happens at the night? So and for example, if it's a wind, if there was wind, it was generated. If there is no wind, what will happen then? So in remote areas where there is no linkages of the supply, or no supply linkages to the grid, or into the remote or the rural areas where there is no, like, the infrastructure provided, so they have these renewable sources. They need to utilize them effectively. They need to utilize them completely. And coming towards the last part, the major benefit for our home Earth, it's the CO2 carbon reduction, which from Nissan. For all of us, our information, Nissan Leaf is just the only vehicle which can provide this vehicle to grid power transfer in current state. The implementation of this technology is under evaluation, is under consideration for most of the vehicles, and it still needs to be adopted. So most of the studies are working on the assumed cases, and that's why we don't have that particular data for what will happen for the user profile. So that's where our paper comes in, and it uses the ANN to predict and train our system for some particular for the particular set of data. So as I mentioned, we need some scenarios. And so what better, they can be multiple. They can be like, unanimous, unlimited kind of scenarios. One person going from one street to the other, one person going from the country to the country, they travel a lot. So these kind of things. But for a start, to train our system, we need some basic guidelines. We need some basic outlines for which we can tell our system, okay, this is it, and these are the scenarios. For this, you learn and adopt it when the situation changes. So for the first case, it's when a car is moving from home, it's fully charged, it goes to work, and then comes back to home. It does nothing. It just goes to work and then comes back. It travels from some traffic. It must have discharged some of its battery. So it needs to decide, like, okay, how much? Okay, if I'm at work, it's not consuming. It's the peak hour from 1 to 4. What should I do? I should be selling this electricity. And so our algorithm decides, okay, this is the time, and how much to sell. For example, if the 30% have been consumed from going home to work, from the battery, and if it sells the less 70%, there is no no benefit. So what's all that about? So it needs to decide, like, okay, how much to sell. We need to go back to home. It predicts that how much will it be recorded, and sell the remaining one, or recharges as much the situation is. The second goes if the vehicle stays at home, and the third one if it is moving on a random route. Okay, so now coming towards the methodologies. Not much of an infrastructure is present that as I mentioned, so we need to analyze it through some algorithms. We need some decision making. So for that, and to train that, we need that RNANN. And for our model, we need to have some battery that needs to be storing that that particular amount of capacity of that of charges. And because that state of charge, that SOC, the state of charge, defines multiple goals, will play a big role in a decision-making process. To design the battery, we are going to use the basic RC circuit model for the battery, with open OCV will be the open circuit voltage, and UC will be the voltage across this RC circuit, which an IK will come across as the amount of the current, and provides the charges at the very end, which will be stored in our battery. And so this will be then modeled in MATLAB, and we can say the estimated and the real-time two state of charges are there for our battery, which we will provide the data for different temperatures and the charging and discharging conditions. So we have a varied cases to decide, and because our battery won't be staying at 100% all the time, it will be changing. Now, defining the cases. So to define the cases, our algorithm, so we made a basic formula for it, which requires three true conditions. So the first of all, the state of charge has to be at some level, which can generate a true signal. Can say, okay, for the state of charge condition, you are right, you are okay. For example, 30% has been used and 70% is remaining. We can use 30% for going back, and an additional like 5-7% for maybe a traffic or some route. So we still have 20% around to sell it back. So we can say it's like, okay, state of charge, tick, it's all right. And secondly, we have a tariff situation. If the tariff is greater than when it was charged, then okay. For example, if the battery was charged at 5 Turkish liras, and the current tariff at that point where the car is assessing, like, okay, if I need to sell it or not, at that decision point, if the tariff is greater than 5, well and good, it goes like, okay, it's a true condition, go for it. And if it's not, it will say no. It needs to decide on its own then. So this will be our the second part of the formula, and the third one, it will goes for our cases. Which case it is involved? It will be built. It was built here in our profile check, where it will check the profile and will decide like, okay, if it is really needed or not. And to train that, we use the train LM algorithm for my method, because it was found to be the most efficient, rather than the gradient ones or the simple regression side. Moving forward, this was for user profile as mentioned, and then it was the third case would be for the cost, as I mentioned. So when all the three cases comes to the true condition, this part and this part and this part is basically triggering. If you compare it with the signal of this one, with the state of charge, it is communicating with the controller, with the electronics, that okay, now we are ready to export, to transfer, to supply the power to the grid, back to the grid. If there's infrastructure provided, it will provide a signal to the user. Okay, just plug it in, and we are ready for the vehicle to grid power transfer. Our ANN results went through the thousand results, and the regression went through the formula was showed like, okay, the regression table went through the unity, and which shows its accuracy, and the conditions which we have adopted, and which are true. And for this, what it was run for 1,000 cases, 1,000 random cases, for example, 1,000 random the amount. For example, in some cases the amount was higher, the amount was lower, the amount was equal. It decided it on its own, and it's trained the system. Now our system is ready to implement. So what it gives for the future, what this the system gives for the future. This system gives the freedom to the vehicle, that it can retrain itself, because this data is also saved in the log file through in the form of array. That okay, this was the user profile, this was the cost, this was the route, and that's the decision I made, if it was yes or not. Because currently we are not having those infrastructure. So in future, when the infrastructure comes in, and the car started moving in through random, through cities, it started traveling through countries. So the more that data comes in, we can again implement, retrain our system to be more accurate in those conditions. And so that's the big benefit of this system, to be more flexible, and it gives less reliability, less what you say, like dependency on some outer cloud systems. It doesn't need to be connected towards the cloud to go back to the servers. It doesn't need that. Wherever your car is, it just one click, you can just retrain it. Then adaptation of the system can assist to smart grid generation accuracies for prevention of blackouts, for the prevention of that dropping that slip. In that case where the frequency goes down or up, created havoc. It's havoc, because if literally if frequencies goes 1 or 2 hertz below the set parameters, it can create catastrophic damages in a power plant. And the implementation of will allow these in fleets and the clusters for microgrid assistance. For example, if there are in future, when for example the 10 trucks are coming in and parking up, and at night they can even supply for the whole microgrid their backups. So that's a very big plus that's going to be studied further. So for in our conclusion, I'll again say these studies and the importance of the vehicle to grid power transfer, and how important it is for in our coming future, and the flexibility this paper provides to this concept, and how easy it makes for vehicles to understand, for vehicles to adopt the system of self-assessing and reprogramming, and the efficient decision making for the consumer in form of the cost and tariff saving, and for the power provider and governments to prevent in the cases of prevention of blackouts and frequency slips, those disasters situations, to avoid that. So results indicated it was successful behavior as expected, as we thought and discussed before, and in our theory, which we were expecting, and we were happy with it when we saw that, and the SOC batteries and the desired limitations, it works perfectly there. So yeah, so the tariffs and references are used. So thank you. If there is any question.
Thank you for presentation. Is there any question? Okay. All presentations in this session have been completed. Thanks for your contribution. Good evening. See you in other session.
Teşekkür ederim hocam.